Let us take a look at number I. So I says we have 2xy, y prime plus y squared equals to 2x squared. So first of all, we want to check to see if it's separable or not. To be separable, you should be able to separate x and y's. But look at this, you have y prime here. You get 2xy dy dx equals to 2x squared minus y squared. There is no way we can separate these two. So because of 2x squared minus y squared, it's not separable. Is it linear? Well, to be linear, we check two cases. If y is a function of x, then it must be of the form a1x y prime a0x y equals to a function in x. So let us check to see if we can write it this way. We have 2xy y prime plus y squared equals to 2x squared. You might say, hey, I can divide everything by y. If you do that, you create a y on the right hand side. So it's not going to be linear if y is a function of x. So far, the answer is no. What if x is a function of y? What if x is g of y? So it means that here you have 2xy y prime equals to 2x squared minus y squared. Then if you flip these, you get x prime divided by 2xy equals to 1 over 2x squared minus y squared. Well, again, if you try to write it in the form that you have a sub 1y x prime plus a sub 0 yx equals to a function of y. So this is the case that x is equal to g of y. Here you see you have x squared on the denominator. So because of this, it's not going to be linear as well. So we don't have a linear differential equation. Is it exact? Well, to check to see if it's exact, we have to write it in differential form. mxy dx and xy dy equal to 0. So let's see. What do I have so far? I have y squared minus 2x squared dx. I'm using this plus 2xy dy equal to 0. The partial derivative of m with respect to y is 2y. The partial derivative of n with respect to x is also 2y. So this guy is exact. What about homogeneous differential equation? Well, to have a homogeneous differential equation, we should check to see if m and n are homogeneous functions. Okay. So m of tx and ty. So remember that we already have m and n, so we get ty squared minus 2tx squared, which is equal to t squared, y squared minus 2x squared, which is t squared, m of x and y. So far, so good. My m is a homogeneous function. What about n? n of tx and ty is equal to, this is my 2xy, 2tx times ty. As you can see, you get t squared 2xy, or you have t squared n of x, y. Again, you have homogeneous functions of the same degree. So we have a homogeneous differential equation. It means that you can either apply the method of exact ODE to solve this problem, or you can use substitution to solve this differential equation.